Hello everyone. So let's begin with the problems of today's contest. So the first problem. The problem states that one day Vlad became curious about who he can have a conversation with on the escalator in the subway. There are a total of n passengers. The escalator has total of m steps. All steps are indexed from 1 to m, and the ith step has a height of I into k. So Vlad's height is given, that is equal to h centimeters, and two people A and B are said that they can carry on a conversation if they are standing on different steps and the height difference between them is equal to the height difference between the steps. Okay, so that means that if the steps are like this and one person is here, then the other person's height plus the height of that step must be same as the person with which he wants to carry out the conversation. So only under this circumstance can the two people continue conversation. Okay. So uh, we need to find how many people he can have a conversation with on the escalator individually. Okay. So how can we proceed in this problem? So our main motive is to make these equal and make the height of the two people equal by adding heights of steps. Okay. So if there are, let's assume 3 steps and Vlad is here and the shorter person will stand at the higher step so that he can match his height. Okay. So but there is one difficulty, that we cannot add any random number to the height of this person. Okay. So the increment will be equal to the height of each step, okay, which is given equal to k. So the height of this person, the second person who wants to reach the height of the first person, can be equal to his original height, let's say x, plus some lambda times k, where k is height of each step. Okay. So if this is equal to height of the other person, let's assume h. If this is equal to h, then they can have a conversation, otherwise they cannot. And lambda also has a restriction that it lies within the range 1 to m. Okay. So that lambda will lie within this range. Okay, so these are the only conditions, and if lambda turns out to be 0, it means that both the people have same height, but in that condition they both have to stand on the same step to have a conversation. But however, it is mentioned that that they need to stand on different steps. Okay, so we need to eliminate this case as well. Okay. So these are the conditions required to solve this problem. So let's have a look at the code. So here's the code for the first problem. I've taken the input of the number of people, the height of each step, the number of steps, and the height of Vlad, and I will store my answer in the variable called count. Okay, so I've taken the height of the person as input, and if that height is a multiple of k, as mentioned, that h minus x, the absolute value of this must be a multiple of k. Okay, so this will be plus minus because it might also be the case that the other person is the taller one and Vlad is the shorter one. So the absolute difference between the height must be a multiple of k. Okay, so the absolute difference between the height is multiple of k. And if that is a multiple of k, then by dividing it by k, it should be less than m. Why? Because there are only m steps. So the maximum height difference that I can obtain would be k into m. So in case the person is so short that he needs more than m steps, then that is also not possible. So that will be rejected by this condition. So such cases will be rejected by this condition. And in case both the people are of same height, then this condition would reject those cases as well. And if all the three are satisfied together, then I can say that it is possible that a person can match the height of flag. And finally, I'm printing the value obtained with the variable count. Okay. So let's have a look at the second problem. So the second problem states that you have an array of integer a of length n. You can apply the following operation to the given array. So what is the operation? Swap two elements ai and aj such that I not equal to j and ai aj are both even or both odd. Okay. So we need to sort an array, and it has been mentioned that we can only swap even numbers among themselves and odd numbers among themselves. Okay, so let's take an example here. So if this is the case, so I can say that I can always shuffle these three numbers among themselves, and I can shuffle these three numbers among themselves. Here E represents even and O represents odd. So, but I cannot shuffle numbers like this. Okay, that I cannot take an even number and an odd number and swap them. Okay, so what should be the case? So since I can sort the odd numbers among themselves and the even numbers among themselves, so I can observe that the position of the odd numbers and the even numbers remain same. Okay, so whichever means so if even numbers were present at index 0, 1 and uh, 5 here. Okay, so in the final array after sorting also, the even numbers must be present at these indexes and the odd numbers must be present at the remaining indexes. Okay, so if I see that after sorting the array in proper order, this condition is maintained, that in the original array as well as the sorted array, the position of the even numbers and odd numbers remain intact. Okay, so if at an index I there was an odd number in the given array, then at that same index I, there should be an odd number in the final sorted array as well. There might be some other odd number, but the number should be odd because we can sort the odd numbers among themselves. And similarly, similar case for the evens as well. Okay. So if we take this first example, it says that 7, 10, 1, 3, 2. Okay. So on sorting, this will give 1, 2, 3, 7, 10. So this is odd, this is even, this is odd, odd, and here 1 is odd, 2 is even, 3 and 7 are odd, and 10 is even. So we can see that the position of odd and even numbers remain as it is. So this is even, odd, 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 even, 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 even. However, the odd and the even numbers have shuffled among themselves. So let's have a look at the code. So here's the code. So I've taken the input array in a variable called in the array ARR, and I've also copied the array ARR in an array ARR2 and sorted the array ARR2. And as I mentioned that for each index, I'll check whether the number present is even or odd. And if it is even, then it should be even in the sorted array as well. And if it is odd, it should be odd in the sorted array as well, in the second array, that is ARR2 as well. And if this condition is violated at any position, then I can say that sorting is not possible, and I'll mark my boolean variable b as false and break out of the loop. And if the variable remains true till the end, then I'll print yes, otherwise I'll print no. So now the third problem. So the third problem states that Vlad remembered that he had a series of n tiles and a number k. The tiles were numbered from left to right and the ith tile had a color Ci. If you stand on the first tile and start jumping any number of tiles right, you can get a path of length p. The length of the path is the number of tiles you stood on. Okay. So Vlad wants to see if it is possible to get a path of length p such that it ends at the index n. So the path must begin at the first tile and must end at the nth tile. And p is divisible by k. Okay. So the number of tiles on which Vlad will step is a multiple of k. And the path is divided into blocks of length exactly k each. So what does this mean? So let's say that Vlad decided that he will jump on 15 blocks. 15 blocks. And the value of k given is 5. So if the starting block, let's say, has a color red, then he'll have to jump on 4 red color blocks after this. After covering 5 blocks of the same color, he can jump on block of some other color. Let's assume that the color is blue. And once he jumps on a tile with color blue, he needs to jump on at least 5 tiles with the same color. Okay. So the next 5 tiles will have the same color. And finally, let's say that the nth tile has a color green. So he needs to jump on that tile. So he needs to jump on 5 tiles with the color green as well. Okay. So before reaching the nth index, he has to jump on 4 tiles with the same color. So how should we proceed in this problem? So if I see that in this situation, the first tile has a color red and the last tile has a color green. And if I eliminate this set, then also I can obtain my answer. So how? Because even if I remove this segment, I'll have 10 tiles, which is broken into 2 segments, each of length 5, and 10 is also divisible by 5. Okay, so selecting an intermediate set of tiles would cause trouble. So it would be difficult to compute an answer. So we will check that if we have an k number of tiles of the first type that we require. So we'll check that whether I have k number of k number of tiles of the second type between the first and the second index, first and the nth index, and the second set of tiles must begin after the first set of tiles. Okay, so once I've got all the 5 reds, then only I should begin with the green tiles. So I cannot jump from red to green and then back to red. Okay, so this is not possible. So I need to cover all the red tiles first and then I need to cover all the green tiles. Okay, so how is this possible? I can keep a prefix sum array of this particular color. Okay, so let's take an example and understand this. So let's take the second test case. 1, 2, 1, 1. So here the first tile has color 1 and the last tile has color 4, and the number of steps that I need, the value of k is given equal to 3. Okay, so let's build a prefix array which will count the number of ones, that is the color of the first tile, from the left hand side. Okay. So here the prefix sum would be 1, here 1, at this index 2, here 3, here again 3, 3, 3, 3, 4, here it would be 4, 4, 4, 4. Similar thing I can do for the nth tile as well. Okay, so I can start from the back and create a suffix sum array which will store the count of the number of tiles with the color 4 from the right hand side. Okay, so that suffix array would have values 1, 1, 2, 3, 3, 3, and 3 till the first index itself. Yeah. So now I can start iterating from the start. Okay. So if I'm at this index, let's say, then I can say that before reaching this index, before and up to this index, there were uh, two indexes where I found the color 1. Okay. And if I check this second array, the next element in this second array, I can say that beyond this index, there are 3 elements which have color 4. So if I move forward, if once I reach this index, I can say that before and up to this index, there are 3 occurrences of the index 1. And if I check the diagonal element of this one, I can say that beyond this index, there is 3 occurrence of value 4. Okay, so what can I say? That up to this index, there are 3 ones present, and beyond this index, there are 3 fours present. So I'll get what I require, that I can jump on the 2 sets of length 6, and each set is of length 3, which is equal to the value of k. So this is how we'll proceed. And there will be one more case, that if starting and ending index both have the same color. So in this case, we do not need this second array. We can simply check the occurrence of the color of the first or the last index up to the final index. And if up to this index itself the occurrence is greater than or equal to k, then I can say that I can select k indices between the first and the last index which have the same color. Okay, so in case if the value of k is 5, then selecting only 5 ones would give me an answer. So let's have a look at the code. So here's the code. I've taken the input array in the array ARR and stored the color of the first element in a variable called C1, of the last element in the variable called C2. Okay. So once I know the color of both the elements, I'm going to store the prefix and suffix sum arrays in the array ARR2 and ARR3 respectively. Okay, and after that I'm iterated from the start and built the prefix array ARR2 and again repeated the same process for ARR3. And if both the colors are equal, then I don't need this second array. I can simply check whether the prefix sum for that color up to the nth index is greater than or equal to k or not. And if it is the case, then I can say that the answer exists, otherwise no. And I can continue for the next element. And if both are different, then as I mentioned that I need to iterate on the array and check whether that for a given index, the prefix and suffix sum of the 2 different colors are greater than equal to k or not for any given index k, for some given index I. And if I find such an index I, then I can simply convert the Boolean variable b to true and break out of the loop. And if b is true, then I can say that there was an index where the condition where this condition was satisfied, and so I'll print yes, otherwise I'll print no. Okay. So this was the third problem. So now let's have a look at the fourth problem. So the fourth problem states that your friend has an array of n elements. Calculate its calculated its array of prefix sum and passed it to you, accidentally losing on element during the transfer. Okay. So your task is to find out if the given array can match permutation. A permutation of n element is an element of n numbers, as we know that from 1 to n all the elements would occur once in a permutation. Okay, and prefix array is built by taking sum of the elements from the 0th index. Okay, so here's an example that if 1, 6, 8, 2, 12 and 15 was the initial array, and if I lose out on 1, then the remaining array would be this, or if I lose out on 8, then 12, then the left out array would be this. Okay, so we need to check whether the given elements belong to the prefix sum of some permutation or not. Okay. So in this problem as well, we need to split it into two cases. That let's say that the array that I've received is x1, x2 up to x of n minus 1. So I've lost one element. So it can be the case that I have lost one element from the start or one element from the end, and the second case might be that I've lost it from somewhere in between the first and the last index. Okay. So if I've lost the element from the first or the last index, then what can I say? So if my permutation was something like this, a1, a2, a3 up to an, and my prefix sum array would be a1, a1 plus a2 and the last element would be summation of all the elements from 1 to n. Okay. So let's say, so what can I say about this array? If I take the difference between consecutive elements, I should get one of the elements of the permutation. Okay. If I have not lost any of the elements till now. So let's assume that I've lost the first element. Okay. So the first value of the difference would be a1 plus a2, because if I have not lost the first element also, so a1 minus 0, that is this difference, would also be one of the element of the original permutation. Okay, so the differences that I'll be left with would be a1 plus a2. Then if I take difference between these two elements, it would be a3, then a4 up to an. Okay. And similarly, if I had lost the last element, then the differences that I'll be left with would be a1, a2 and an minus 1. Okay. So what can I say about this case? In this case, if I take the difference of the elements, difference of the consecutive elements, and keep an array of size n, because this is a permutation of length n, and keep marking all the elements as visited once I've obtained them in the difference. So once I've achieved this difference a1, I'll go to index a1 and mark it as visited. I've obtained a2, then I'll go to index a2 and mark it as visited. Okay. So after I'm done with all the operations. So in this case, I'll be left with only one element which is not visited till the end. Okay, because after taking the difference, I've lost an only. Other than this, I've lost no other element. So what can I say? That if my count of the non-visited elements is equal to 1, then it is always possible to obtain a permutation out of the given array. Okay, so this was one of the case, and the other case is that um, if I've lost some element in between the array, in between or even from the start of the array, both of them would lie in the same case. So let's say that this was my permutation, and my prefix sum was something like this. Plus So this is my prefix array, and I've lost this element. Okay. So now taking difference of the consecutive element would give me A2 plus A3. A2 plus A3. Other than this, I'll always have A1, A4, and all the other elements are as it is. Okay. So what can I say about this element? Okay. So this element might get equal to some other element of the permutation. For example, if I get two fives while taking the difference, it might be the case that one of the five is contributing to 5 itself, and the other 5 might be contributing to 2 and 3, and the remaining left out elements might be 1 and 4. Okay. So here A2 plus A3 corresponds to this case. So we can observe that if the repeated value occurs twice, then it contributes to the number itself as well as two other values. Okay. But if the repeated number appears more than 2 times, let's say assume 3 times, then this would contribute to 5. This would contribute to, let's say, 2 and 3, and this would contribute to 1 and 4. Okay. So, but it is said that we have lost only one of the number from the array. Okay. So, occurrence of such a case, that is summation of two numbers would give me one of the differences, would occur only once. Okay. So, if the repetition of a number occur more than 2 times, then I can say that a permutation cannot exist. So now there are two cases. So I've eliminated one case, that repetition of any element, repetition of a difference more than 2 times would not give me an answer. So what I'm left with, that none of them are repeated, or one of the number is repeated twice. Okay, so let's deal with this case. In case none of the numbers are repeated. So let's take an example here. 1, 3, 4, 5. And here the prefix, is 2. So the sum would be 8, 13, 15. Okay. So let's say that I lose this value, 8. So I'm left with 1, 4, 13 and 15. In this array there is no repetition of value. So 3, 9 and 2, and 1 minus 0, 1. these are the difference values that I obtain, and here there is no repetition. So there should be no repetition in the value of the differences and not in the prefix sum array, because in prefix sum there would be no repetition at all. So here we can see that there is no repetition. So if I take these values, I know that the prefix sum array that I have been given has a length of n minus 1. Okay. So the permutation would have a length n. So if I create an array of size n up to n and keep marking the elements which I am obtaining, and the value of the element is less than n, less than or equal to n. So I've obtained 1, I'll mark 1. I've obtained 3, I'll mark 3. I've obtained 2, so I'll mark 2. Okay. So here in this case, as I mentioned, that two of the numbers might be getting merged. Any two of them might be getting merged. So what can I do? I will iterate on the array and check which of numbers are not visited. Okay. Once I find out those numbers, and if more than two numbers are not visited, then I can say that it is not a permutation, that I cannot get a permutation. And if the number of numbers that are not yet visited are equal to 2, and the sum is equal to this value, that is the difference value that did not get a place in the array itself. So in this case, I can say that my answer will exist. Okay, like in this case, 9 would contribute to 4 and 5. That is, if I place, let's say 8 or 9, any of the numbers in between, then this difference would give me 4 and this difference would give me 5, or vice versa. Okay, so this was one of the case, and the other case might be that there is repetition in the difference as well. So let's assume this is my permutation. So let's assume that the difference value that I obtained is like this. Okay. So these are the difference of the consecutive elements in the array that is given. So in this case as well, I need to do a similar process. Here I'll take 1, I'll mark 1 as visited. I'll take 4, I'll mark it as visited. I'll take the first occurrence of 5 and mark it as visited. And once I get the second occurrence of 5, and I'll see that 5 is already visited. Okay, so I need to repeat the above process again. So what was that process? I will check that whether two of the numbers are not visited or not in the array. So in this case, two of them are not visited. Okay, and whether the sum of those elements is equal to the number that was excess. That is, here 5 was repeated twice. So the sum of the elements that were missing is equal to 5. And if that condition is true, then I can say that I can form a permutation. Otherwise, no permutation is possible. So there were too many cases that we need to handle. We could have merged some of them, but this is what I came up during the contest. So let's have a look at the code. So yeah, I've taken the input. Okay, and I'll store the value of repetition, number of repetition in the difference in this variable named rep. Okay, and I've created a hash set to check whether a number is repeated or not. And whenever I find that a difference has already been computed, and it is occurring again, then I'm incrementing the value of REP by doing REP plus plus. And if repetition is more than twice, then I can simply say no, because repetition more than twice is only possible if more than two elements are uh, removed. Okay, so removal of any one element would not cause repetition of a number more than twice. Okay, so once dealt with this case, we'll check the second condition, that whether a number, all the differences are unique or not, or any one of the differences is getting repeated. Okay, so here the val variable also stores the difference that is being repeated. Okay, so if that is equal to -1, then I can say that none of them was repeated, that none of the differences were repeated. And I've created an array ARR2 of size n plus 1, and I've iterated over the set, and and there will be one element whose sum would be greater than value of n, and I've stored that sum and stored that number in a variable called n, and uh, I'm treating ARR2 as the visited array and marking it with 1 once I find an element in the hash set. So after doing so, I'll calculate the sum and the count of the numbers yet not visited. So if that count is equal to 2, if that count is not equal to 2, or the sum of the numbers still remaining to be visited is not equal to the sum of the number that was larger than n, or the count is not equal to 1, okay, so I'll mark B as false. So in this only I have handled the case that a number has been deleted from the edge. In this case, the count value of the deleted number would not be equal to 2 but will be equal to 1. So after marking the entire array, there will be only one element that is yet not visited. And in that case, we can always obtain an answer. So I've marked B as true. So, and the second case, that a difference is repeated twice. So I've kept track of which number is being repeated twice here. And at the end, I've checked whether the sum is equal to the number that was repeated twice or not. Sum of the elements which have not yet been visited is equal to that element or not, and whether the count is equal to 2 or not. So if the number of visited numbers is not equal to 2, then I'll mark B as false and break out of the loop. And if after checking all these conditions, if the value of B remains true till the end, then I'll print yes, otherwise I'll print no. Okay. So this was the fourth problem. And now let's have a look at the fifth problem. So the fifth problem states that alchemist Nastya loves mixing potions. There are a total of n types of potion, and one potion of type I can be bought for CI coins. Okay. Any kind of potion can be obtained in no more than one way, by mixing from several others. Okay, so this means that we cannot obtain a potion by mixing, so there won't be more than one combination which would produce one potion. Okay, so there are only two ways of obtaining a potion. That is, I'll mix a combination of other potions and produce one, or I can directly buy that potion by giving CI number of coins. Okay, so as an experienced alchemist, Nastya has an unlimited supply of K types of potion, but she doesn't know which one she wants to obtain next. To decide, she asks you to find, for each I from 1 to n, the minimum number of coins she need to spend to obtain a potion of type I. Okay, so let's understand this question with an example. So in this question, it is mentioned that there are 5 types of portion. 3, 5, 10. And these are the indexes of the portion. And alchemist has unlimited supply of this one, the portion present at index 3. Okay. And it is said that the portion 1 can be created by a combination of portion 2, 4 and 5. The second one cannot be created by any means, so it has to be bought. The third one as well cannot be created by any means, and it has to be bought. The fourth one can be created by combining the portion 3 and 5, and the fifth one also cannot be created but has to be bought. Okay, so let's model these input as a graph. So to create one, I need the value of for creating 2, 4 and 5. Okay, so the minimum amount for creating the portion 1 would be the sum of the minimum values of creating portion 2, 4 and 5, or the value of the portion 1 at which it can be bought. Okay, so let's model the other example, other nodes as well. First, second, third, fourth. So the fourth portion can be created by a combination of 5 as well as 3. So we can see that we can take help of topological sort to solve this problem. We can begin from the nodes which do not have any dependency on other nodes. Okay, in this case 2, 3 and 5, and because 2 has to be bought and cannot be created by any other portion, there is 3 also needs to be bought, but since it has been mentioned that there is an unlimited supply of portion of type 3, so the cost is 0 here. The cost of buying 2 is 8, and the cost of buying 5 is 3, 4, 5, 10. Okay, so I can create portion 4, and the cost of portion 4 here is 5, but I have two choices. Either I can buy 4 directly at a cost of 5, or I can buy 3 and buy 5 at cost 0 and 10 respectively, mix them and create portion of type 4. Okay, so here we can see that it is more feasible to directly buy portion 4 at cost 5. Similarly, so the minimum value of creating portion 4 is 5. Okay, since 2 cannot be created, the minimum value is 8. And since 5 also cannot be created by any means, the minimum value is 10. So now, since I know the minimum value for creation of 2, 4 and 5, I can compute the minimum value for creating portion 1. So to create portion 1, I can either directly buy it from the market, or it will be the summation of 8 plus 5 plus 10. So it will be a summation of 8 plus 5 and 10, which would give 23. Okay. So, and it is also mentioned that it is guaranteed that no portion can be obtained from itself through one or more mix. So we can be sure that there is no cycle in this graph. So we can apply topological sort from the vertices within degree 0 and continue this process until all my nodes gets covered. So in this case, I'll begin with 2, 3 and 5. After I've covered these 3 nodes, I'll cover the node 4, which is dependent on node 3 and 5. And after that, I'll cover node 1, which is dependent on 2, 4, and 5. Okay, so let's see the implementation of this. So here's the code. I've created two adjacency lists to store the matrix. One to store the straight edges, and the other one would help me to get the value of the neighbors. So I'm storing the back edges, just the opposite of the edges stored in ADJ in ADJ2, so that I can iterate over the neighbors of node 1 and the other node, so that I can compute the value, this value, that is the minimum value, by taking the sum of the neighboring nodes. So I've stored the opposite edges in ADJ2 and stored the forward edges in ADJ1. So here it is. And I've created a cost array as cost, and I've initialized all the costs with the array provided. And I can say that the nodes which I have infinite supply of, the portions which I have infinite supply of, will be obtained at the cost of 0. So I do not need to buy them, and I can say that the cost of obtaining that portion would be 0. So I simply need to do a traversal, a BFS traversal, or more appropriately a topological sort like process, and I'll add all the nodes with in degree 0 in the queue. And once I'm taking out the element of the queue, I'm checking the value of its neighbors. And if the sum of the values of its neighbors is less than the cost it has currently, then I can update the value of cost and add the next element which has in degree 0 in the queue, and continue this process until I obtain the final array cost.